Okay, here's the last part of this chapter. We'll talk about there are two atomic model. One is called the J.J. Thomson's Plum pudding model. This is J.J. Thomson. And another scientist, actually his student, called Ernest Rutherford, created another nuclear model, atomic model, after his proposal on the Plum pudding model. So Rutherford make a better judgment later on. What I want you to do is to finish page 13, filling in, describing how Plum pudding model looks like, and filling the blanks for the Rutherford nuclear model. To do that, you can read the textbook, these 2 pages, and I will also want you to go through the video, 2 video here. I'll put a link in the description. The first video is about how this device made by J.J. Thomson, that is a tube with, here you can see there's a power supply with high voltage. You can see kV here with a high voltage. So basically what he did is apply a high voltage to different metal, and he will find out that no matter what metal you place, there will be the same kind of substance emit from, like, between these 2 poles, and that later on discovered by him, like this one, as electron. So he's the one actually discover the electron. Right? It's actually amazing to see. So try to go through the video. These 2 people explain what happened very well as well. So try to go through the detail on how J.J. Thomson discovered the electron. And the importance of this is this cathode ray setup helped him to get Nobel Prize, first of all. Second thing is leads to his thoughts on the next thing, on how atom looks like, Plum pudding model. Think about this. Before Thomson, all the scientists before him only knows that the atom are more like a billy ball. That means there's nothing else but a ball that is spherical. But because of the discovery of electron, then he started to think, hey, maybe, just maybe, that in the atom there are something like those kind of things in the plum pudding. Those plum in the plum pudding add like the negative charge, and the cake itself is the positive charge. So this is how it looks like, and try to describe it in the notes here and annotate them. Okay, so I'll put the link in the description. Try to finish the 2 video by yourself, and we'll check the answer. Okay, so here's the answer. For J.J. Thomson, basically, like I said, the original idea perceived by the scientists as atom is just a billy ball, so just like a ball like this. We don't know what's inside, and we thought it's completely solid. So like fish ball or any other meatball that you eat, inside is completely solid. That's what we thought. And only after J.J. Thomson discovered the existence of electron, then he think, hey, maybe it looks more like this. Atom, actually, he tried to revise it. So it's more like having some plum inside. And then when you try to apply a high voltage that set up the electric field, then this plum will come out. So these are some negative charges, which is electron that he find out. And then the remaining part of the cake, that means the main part of the cake, would then be positive. So this is how he perceived and suggested for the plum pudding. And in fact, this plum pudding is later on rejected by the experiment from Rutherford. And this plum pudding, I think, only lasts for around 20 or 30 years. And I think this is a great lesson for us to reflect on. Think about this. By the time J.J. Thomson was like a very famous person, obtaining the Nobel Prize, he suggested that, and then actually many people, or even in a textbook, would say, or at least the book that he wrote, would say that, hey, this may be probably the model that is correct. And in fact, later on we find out it is not the case. So it's something that I think for all of you, you can reflect on is that is the nature of science. itself that for the things that you were told right now probably may not be correct perfectly, especially for those which were just discovered. For example, nowadays in 2020, the things that people are working on is usually in the galaxy, so for astrophysics stuff, or the very tiny stuff that is quantum mechanics, QM, or quantum mechanics, very tiny stuff. And if you hear about something like quantum computing or quantum entanglements, those things are very fascinating, but whether or not it is really the case or not, it still takes more time to do experiment, to test, to see how it works. So I think this is the nature of science. For the things that people propose, it may not be perfectly true. I mean, even for this Nobel Prize winner. So be more skeptical, and even his student, you can see here, Rutherford, would not fully trust what he said also. I think this is the best thing of science, and this is the attitude that you should have as well. So for what Ernest Rutherford did, actually, the so-called experiment is actually done by his students, 2 of his students as well. So he was actually the supervisor. But anyway, what that experiment did was something like this. Okay, I'll again put the link in the description. This is a really nice simulation as well. So here what you can see is the actual model from the, well, actually I shouldn't say actual model, but this is a model that proposed by Rutherford that he think that it should be. To a certain extent, is correct as well. So what happened is, if you try to have the gold foil, I assume you read the textbook, you should know this is gold foil, and if you try to zoom inside, there are many atoms of gold, and if you try to shoot the alpha particles to it, the amazing thing you find out is, if J.J. Thomson is correct, so this is a Plum pudding model where negative and positive charge would just simply be together, then what will happen is, sorry, not this one, Plum pudding model. If this is true, then what we would expect to see is, by bombarding the alpha particle, it will simply be like this. I mean, nothing would really happen. So they will simply be going straight, maybe. Yeah, if we try to add, more energy, it would still be the same, because the whole atom in itself is neutral, and so nothing should happen. Or the other thing that should happen is, since it's completely solid still, because if you remember the cake itself is fully solid and positive, and so what happened to the simulation, it should be probably those alpha particle would not be able to penetrate through it, so they will all got blocked by the gold foil. However, what Rutherford find out in his experiment is that most of the alpha particle actually they got passed through. So in fact, what they find out is, at the back of the gold foil, they can detect most of the alpha particle. I think, as I remember, it should be about 95% of the alpha particle. Only for a few, you can see, for maybe a few of the alpha particle, let's say just now this one, it was heading towards the nucleus, all right, this nucleus, and because of alpha being positive and nucleus being positive, so they got deflected. But still, if you try to put a sensor at the back of the gold foil, you can detect it, except like this one just now. I hope you can see it. Just now it got deflected, so this is a very minimal, very minority in the experiment that they can detect. So that, I think that is like 1% only. So that conclude the model you can imagine is that he can never see, of course, but the model you can propose and that actually fit the result could only be having the positive nucleus concentrated in the middle rather than the Plum pudding model. So this is how scientists work as well. I mean, for most of the time, especially when you're studying things are very small or very big, you may not be able to see it directly, but you could try to create some model to hypothesize how it should look like. So this is how science works as well. For the answer on your notes, so this will be the answer. So what you can say about is the gold foil is bombarded. That means it got, you know, many alpha particles got shot towards it, and which are positive charge for the alpha. And the result is most of them will pass straight. Only few of them will repel so strongly that will bounce back or deflected at a large angle, like what you could see in the simulation. Very few would be like this one, right, will bounce back. And so in that case, we Rutherford and of course his student as well can conclude that the atom must be largely empty, and that's why those alpha can pass through it. Only in the most center, concentrated center, the most of the mass will be there, and it is also positively charged as well. So this is the finding of Rutherford, where it basically rejects the idea from J.J. Thomson, and this is widely accepted afterwards. And this is how the experiment is done, using a gold foil and the alpha source, and make the Rutherford model. Okay, so let's finish the last page of this chapter. Pause the video now, do it first, and we'll check the answer. Okay, so this question is actually quite straightforward. So what you have to do is that for the question for first part, it tells you that to complete the path for A, B, and C. So it's simply just follow what it said. So it said A is directly towards the gold nucleus. That means it would deflect. So that's why you draw like something like this. All right. It doesn't matter if you go like this or you go more like this, is fine. It doesn't really matter. Part B, B is pass close to a gold nucleus. So close to gold nucleus. So you may deflect. So imagine you have a small tiny gold nucleus here, then you got deflect like this. All right. Again, if you like to deflect down, is fine. All right, but you still pass through the whole gold foil. For C, as you said, it does not pass close to any nucleus, so it simply goes straight because most of the space are empty in the gold atom. Part B, it basically asks you to state and explain how this result will support the existence of those nucleus in the gold atoms. So first of all, you have to describe what happened. 1 and 2 is describe what happened. Describe that only small amounts of alpha particle, only small amount, will get deflected or reflected. So describe what happened. That means A is the minority. And then number 2, you should say most of the alpha particle pass through the gold foil straight without deviation. That means C is the majority. And because of this result that you can measure, then there must be, to conclude, there must be a concentrated mass, only concentrated at the middle with a small volume. Okay, so that's why we find out, Rutherford suggested the new model. That's the end of the chapter.